Welcome to our business track of the Data Science Salon YouTube channel. In this talk, we have Thulasi, Nambiar, Senior Manager of Marketing Data Science at Prosper. As most companies understand the power of data and learn of the advances in data science, a common theme appears. The one where companies hire single data scientists and expect astronomical changes to the technology and growth. What is lacking in most cases is the discipline to understand that, like many other things in life, data science is a process, a spirit, and not a marathon. Building a team from ground up takes time, and if done effectively, can in the future lead to substantial competitive advantage for your organization. Thulasi talks about how to do this in a structured and most optimized way. Enjoy.
Hi, everyone. I'm extremely thrilled to be here today. I'm Thulasi. I'm here to speak about the process of building a data science team from ground up. So, as most companies understand the power of data and learn of the advances in data science, a very common theme appears that companies hire one data scientist and expect astronomical changes to technology or growth. But what's lacked is the discipline to understand that data science is a process. It's a marathon, not a sprint. And like everything else in life, it takes time. But building a team from ground up requires the patience and processes, and if done efficiently, can give you significant competitive advantage over the years. Now, I would like to talk about how to do this in a structured and most optimized way. But before we dive in, I want to talk about a few common themes that we hear in the industry, and primarily stemming from the fact that this is relatively a very new field. We are all figuring out, exploring it as we speak. So a good example is the expectation is that we'll build a model and it'll give us 900% growth year over year right away. The reality is that it requires many years of infrastructure and technology build and engineering resources before the model can be deployed into production. But we forget that aspect and we think that any model can give us that competitive advantage right away. Another one, and probably one of my favorites, and I believe many of you might have heard, is one machine learning scientist is all we need. Put out that job posting for data scientists and get started. The reality is, machine learning is an ecosystem. It doesn't stand alone. And it requires a ML ops person, a business expert, a data analyst, a product manager, and a lot more. But we always lose sight of that aspect of the ecosystem and think single-handedly the competitive advantage a data science model can bring. The next one, and this is even common within folks with analytics experience, that we can build a quick and dirty model in a week. The reality is we are in this business to make data-driven decisions that fuel growth and profitability. The end goal is to drive the business and help make the right decisions. For that, we need the ability and patience to look at the data in the right way. So if we build a quick and dirty model in a week, it's quick, it's dirty, but it's inaccurate. A 66% accuracy or a 99% overfitted accuracy does not generalize and does not hold true in time. And the last one, and this typically happens in companies who've been around for a few years, we think we have the data and we can spin this all up in a week or two, because that's what you hear from everyone else in the industry. But as many of you know, and most of you who have done data science or who have led data science would know, 70% of the time, a data scientist spends is in cleaning and feature engineering the data to get it ready for algorithms. It all comes all the way to the end, but that 70% is a little bit of art and a little bit of science. The art is in understanding the business and understanding the variables and creating the variables in such a way that the machine can pick up better. And the science is the unprecedented computing power that, thanks to the progress in technology, you and I have in our hands. So with that, I think most of us understand now why it requires a process, that it's not a single standalone system. It's a beast in all its fairness. And what are the processes to follow? So what I have here is a playbook, how to build in a structured way and what to look for in every step of the way. We start with business intelligence. We democratize data in the organization. We get data in the hands of every single person so that they can steer the organization in the right way. Your customer service folks, your sales folks, your marketing folks, product folks, and engineering folks. The next step, once you have that, is leveraging data for advanced insights and analytics. This is the stage where we answer more complex questions with the help of data, and you leverage that information to make a strategic decision. And at the very end comes machine learning and AI. And it's a long wait, but if done properly along this process, this step is significantly simpler. And if not years, it will only take some time. So let's get there one by one. First step, building basic business intelligence. Fundamental question that we have to answer when we start this process is, what is our most common use case for today and 5 years from now? Technology stack is changing so much that it's given that the technologies that we use today will become obsolete in a couple of years. But we still need to have a vision for the next 5 years to get there. So question one, what kind of warehouse do we need? Do we build on Redshift that comes with an entire Amazon suite of products involving S3? Or do we use BigQuery that relies on Google Cloud Platform and comes with its own suite of products, starting from recommendation engine to AI platform to Google Cloud Storage? Or do we use Snowflake that has integrations with Databricks, for instance? Again, we don't have to answer everything right at the beginning, but we have to have some sense of where we are going. The second question is, what is the language of choice? Should it be Python? Should it be R? R has capabilities of matrix multiplications that far outweighs Python's. But Python is increasingly becoming a language of choice amongst the data scientists because of its ease and resources. And again, goes back to, are you planning to integrate this into your product, or is it going to be a standalone product? A lot of this need to be answered ahead of time to have a smoother journey in front of you. Again, as we all know, all of these will change with time, and you will end up building new toolkits, or you will refactoring some of it. But you can save a lot of that time by thinking ahead. The last question, what visualization toolkit do you want? Do we want a data studio or a mode or a gold standard Tableau? And what surrounding infrastructure do we pick? A deployment infrastructure is as important as building a model. Most of us who have done this would probably know that it requires a lot of engineering resources, ops resources, and building a model in production is a completely different ballgame compared to building it. And with that, these are the key research ideas to think through when we are thinking of building a data science team. And the skill sets that you would look for at this time are engineering and business intelligence. Engineering first, and business intelligence or analytical experience is second. And we should look for people who can wear multiple hats, who are more of generalists than specialists. They know a little bit of data analytics, a little bit of engineering, enough to put these pieces together. And the key priorities at this stage is to build performance monitoring dashboards and democratizing data. Like I said, have data in the hands of the organization, and then every nook and corner of the organization can steer itself well. Once we have that, we move on to the next step, which is building an advanced analytics and insights team. Here we leverage the data infrastructure we have already built to solve business challenges, such as what's the right pricing strategy? What should be our target customer segment? Or how can we leverage statistical testing for feature improvement? For instance, a green button at the top right or a yellow button at the top right, which one makes people click on the ad more? Or do we go for the niche segment, or do we go for a generalized segment and compete with the city and the chase of the world? And with the right data, these answers are really easy to solve for. And the key skill set that we need at this stage is to build a data analytics team. And we should look for people with prior analytics experience. And again, always in the earliest stages, it's better to have people who can wear multiple hats so that they can figure out and steer the direction. Now, the analytics at this stage helps strategic growth, optimization, profitability, and here we leverage data to make informed decisions. And then when you finish this, we are at a place where we can finally build that dream team of machine learning and AI. The way data can help scale and bring competitive advantage at this step is significantly higher than any of the prior steps. And the volume of data that we can harness and get answers from. For instance, who are the most creditworthy customers to lend among 200 million plus individuals? Most optimized route for thousands of drivers. Most responsive and profitable segment when we are talking about 100 million individuals. When we think of rent prediction algorithms accounting for unstructured data, do we know that the rents go higher when it's next to a highway? Or would a yellow wall versus a white wall make a difference, and how much? The nuances of it, it's so important that a machine learning model, when built well, is a beautiful mathematical product. And this is where we start building the data science team with a data scientist, a data engineer, a machine learning ops person, an AI product manager. I want to take a step and discuss about the machine learning ops team. For people who have been part of engineering teams, you would know a DevOps is a key function to any software engineering function. Similarly, a machine learning ops supports machine learning from an engineering and deployment standpoint. And this is a team more often than not last hired, and it's too late by then. It's important to keep all these teams in mind. And as always, hire people who have end-to-end build and deployment experience first, and then follow it by specialists. Remember, the scale and optimization a machine learning model can bring, and again, if done well, is unprecedented to anything before this. And it gives a significant market distinction. But always remember at least the very first of the hires to be people who have enough experience in the industry and not completely new in data science person. Because there are certain things that you learn at work which you don't otherwise. For instance, you could see a model that has like 98% accuracy. More likely than not, it's overfitting and it will not generalize. You want people to think, would this variable, does it even make sense for the business? Yes, we're talking about thousands of variables, but if it doesn't, what if we took it out? Would the accuracy increase? Would the model become more explainable? A lot of interesting concept around at this stage. One of them is explainability. A lot of data science teams are struggling with that. You build a model and it's such a black box that nobody understands what's going on, neither can you explain. Especially if you're in industries like financial technology or regulated industries, you have to know what the model is so that you can exclude and make sure there are no biases. The second aspect we have to be careful at this stage is maintaining an accuracy of the models over time. What do I mean by that is all models degrade. Given time, we have to make sure that these models are rebuilt or reassessed so that the accuracy is kept at par. And that in itself is work. Building is half the work, but maintaining is the other half. The second is ethics. It's a topic that merits a completely different conversation on its own. But being ethical in machine learning very much can start with thinking about what variables you're putting in and making sure there are no biases in modeling. And the third aspect to think of at this stage is sustainable development. Yes, we hired one data scientist, built a model, and the person left with no documentation. And the rest of the teams are trying to figure out, okay, now where do we go from here? And sustainable development implies that just like in any other field, that there is a structure, there is a process, and there is documentation. With that, we almost reach the end of this presentation. So to summarize, very first thing I would say is be patient with the process. It's a marathon. It's not a sprint. And do it in a very structured way that can get you results every step of the way. Hire the right person at the right time. Single data scientist at the beginning of your data journey might not necessarily be the right person. But again, it depends on your use case and the product that you're building. While having a vision of future stack is important, there is nothing worse than having tech debt. You build years building, then you build more years refactoring, and further more years assessing new technology and migrating. All of this can be avoided if we think through all this ahead of time. The future tech stack can define development speed and tech debt. So make sure we address carefully at the very beginning. Then constantly assess effort versus impact. A machine learning model is not always the right solution. Your business might need a use case, an innovative one that can be built out of, a spin out of, something much simpler and takes 1/10 of the time. So have that perspective in mind and the end goal. And like I said, building is half the work, the other half is maintenance. And if I can leave you all with one thought today, that would be to have a data vision. Easier said than done. To think through, to plan out what's coming up ahead of us and potential use cases and start building towards that. That vision coming from a leader is unparalleled in any organization in the data journey. And thank you so much for listening to me today. I end with this one image, is one of my favorites. Most of you might know, called a pale blue dot, the image of Earth, the moon. And what it signifies is to keep at it. We did not land in moon overnight. We worked hard, we had processes, we experimented, we struggled, but we eventually figured out. And this picture reminds us all that eventually we landed. So thank you so much again, and really appreciate listening me. Happy to answer any questions you have.
That was a presentation by Thulasi Nambiar, Senior Manager of Marketing Data Science at Prosper, and she talked about how to build data science teams in a structured and optimized way. If you enjoyed that presentation, please make sure to sign up to our channel below. Thanks.